section 4.8. The first two problems in this section are simply looking at a graph and then determining what the x-intercepts are. Let me see if I can. Okay, on this first graph, and the x-intercepts are just these 2 points where this parabola crosses through the x-axis. So if you're looking at this graph, this one crosses through right here. So the x-intercept would be, and remember this is going to say type an ordered pair because these are points and each point comes from an ordered pair that has an x-coordinate and a y-coordinate. So the x-coordinate is going to be where it lies on the x-axis, which is in this case -3. The y-coordinate for the x-intercept is always 0. The y being 0 is the reason that the point lays on the x-axis because it hasn't gone up or down at all. So that's why the y is 0. So there's that one. Then use a comma and then put in this one. So this one crosses through the x-axis at 5, 0. So those are the two x-intercepts. Now, when you talk about x-intercepts and solutions, those two words a lot of times are interchangeable. These solutions are simply the x-coordinates of these two x-intercepts, which would just be -3 and 5. All right, on the next one, same thing. The x-intercepts, this one would be at -2, 0. And this one, again, since it's right on the hash mark in between the 4 and the 6, it'll be at 5, 0. So there's my x-intercepts, which means the solutions are x equals -2 and 5. Okay? These are talking about solutions. These do not have parentheses around them. They're just the two solutions. You only use the parentheses when you're talking about the x-intercepts, the actual points. Those have parentheses around them because those are the ordered pairs. Okay, the next two problems, the last two problems are word problems. On number 3, it says, a wire is stretched from the ground to the top of an antenna tower. The wire is 35 feet long. The height of the tower is 7 feet greater than the distance from the tower's base to the end of the wire. Find the distance and the height of the tower. So let's think about what this would look like. If I'm talking about a wire being stretched from the ground to the top of an antenna tower. So this would be my antenna tower, and here's my wire. So this right here, so if the wire is stretched to the ground, here's the distance from the base of the antenna tower to the bottom of the wire. So let's write in the numbers or the information that it gives me for each of these. It tells me that the wire is 35 feet long. So here's the wire. So I know it is 35 feet long. It tells me that the height of the tower, which is this right here, is 7 feet greater than the distance from the tower's base to the end of the wire, which is this distance right here. So here's the height, and here's the distance from the base of the antenna to the wire. So it tells me that the height is 7 more than this distance right here, which means, I don't know what the numbers are, but if you call this x, this is going to be whatever x is plus 7 more. So before we get into solving this, we need to remember the Pythagorean theorem, which states that in a right triangle, which is the shape that this would make, a squared plus b squared is equal to c squared. Now, a squared and b squared are the two sides right here, okay? The c squared has to be this side right here, which is called the hypotenuse. It's the diagonal side of that right triangle. So let's fill this in. We'll call this a and this b. So I need a, but square it. So x plus 7 squared, plus this side squared, so plus x squared, equals this side squared. So 35 squared gives me 1,225. So let's write this side out. Let's see what x plus 7 squared means, which is x plus 7 times itself. So if I FOIL this, x times x is x squared, plus my outer x times 7 will be 7x. My inner would be another 7x. And then my last 7 times 7 is positive 49. Now if I put these 7x's together, I would have x squared plus 14x plus 49. So that took care of the x plus 7 squared. Now I'll just bring down this x squared equals 1,225. So now let's look over here. We can combine these two x squared since they're on the same side of this equal symbol. I can put these together. So I've got 1x squared and another 1x squared. So I actually have 2x squared plus 14x plus 49 equals 1,225. So now I notice that I am solving what's called a quadratic equation because it's an x squared equation. And if I'm going to do that, I need to set the equation equal to 0, which means I need to bring this 1,225 to this side. So I'm going to subtract 1,225 from both sides so that I can have a 0 over here. All right, on the left, I'll bring down the 2x squared and the 14x. Then I have 49 minus 1,225, which gives me negative 1,176 equals 0. Now, this right here, I'm going to try and solve this by factoring. I noticed that they all divide by 2, which is good because I can pull a 2 out of all of those, which means divide all those terms by 2. So that'll just end up being x squared, 14 divided by 2 gives me 7x, minus 1,176 divided by 2 gives me 588, equals 0. Now, I need to factor this trinomial, and since we pulled out the 2, that's the good part. Because if it's just x squared, I know that this would have to be x and x. Now, here's the difficult part, and I'm going to show you a little trick. I have to find, the numbers that go here have to do two things. They have to multiply to equal negative 588, and at the same time add to 7. So if you have to find multiples, or factors of negative 588, that's the hard part of this. Now, if you look in your calculator and you go to your y equals, whatever you're trying to find the factors of, which in this case is negative 588, type that in. So negative 588, oops, and then hit divided by, and then hit your X button, which is the button next to the alpha button that's got the X and the T on it. So let's type in the X. Now, let's look at the table of this. So look at this table. What this is showing you are numbers, everything in the X column and the Y column. If you multiply those numbers together, they equal negative 588. Okay? So, I also want to know which one of these adds to positive 7. So let's go back to the y equals and go down. So type in exactly the same thing, negative 588 divided by x, and then do a plus x. Now when you go to the table, here's what you're looking for. You're looking in this third column for that positive 7, because that's adding these two columns together. So I know that these two columns multiply to negative 588. So now I need to know what these two columns added together equal, and I'm looking for them to equal positive 7. So here I found it. If these two numbers, when you add them, they give you positive 7. So negative 21 plus 28 is 7. And I also know these two numbers multiply to negative 588, which means I have found the two numbers that need to go in my factorization, which happen to be negative 21 and positive 28. Negative 21, positive 28. Those numbers multiply to negative 588 and add to 7. So here's the two factors that I'll need to set equal to 0 to solve them. So solve these for x. So here I would have to add 21 to both sides. So x equals 21. To solve this one, I'd have to subtract 28 from both sides. So here, x equals negative 28. Now, here's my two answers that are possible answers for x. Now, let's think about what x represents. It represents the distance from the bottom of the antenna pole to the wire, which means it's a distance, which means it cannot be a negative number. So the x is represented by 21. So now I know that this distance right here is 21. And I also know what this distance is because it told me that this tower was 7 feet longer than this distance was. So 7 more than this would just be 28. So the first thing it asks me is the distance from the wire to the tower is 21. The second thing it asks me is the height of the tower, which is this distance, is 28. Okay, number 4, the last one in this section, is another word problem. Okay, its setup is also going to make a right triangle. This one says the foot of an extension ladder is 7 feet from a wall. The height of that ladder, the height that that ladder reaches on the wall and the length of that ladder are consecutive integers. Well, if they're consecutive integers, what that means is the numbers are one after another. Okay, so how long is the ladder? So let's draw this out again. Again, it will make the shape of a right triangle. And it says the foot of an extension ladder, so here's the foot of the extension ladder, is 7 feet from a wall. So it's this right here, this distance is 7 feet. The height that the ladder reaches on the wall and the length of the ladder are consecutive integers. So these are going to have my x's. So if this is x, and this is the very next number, that's what consecutive integer means. That means it's just going to be whatever x is and add 1 to it. So again, let's use our Pythagorean theorem, knowing that whatever a squared plus b squared has to equal c squared. So remember, this is my a and b. So this number, which is x squared, plus 7 squared equals this side, which is x plus 1 squared. All right, so let's simplify these two sides. So I can't do anything with x squared. Plus 7 squared just gives me 49. Equals this side, x plus 1 squared means x plus 1 times x plus 1. So let's FOIL this. So x times x gives me x squared. The outer x times 1 is 1x. The inner 1 times x is another 1x. And then my last 1 times 1 is 1. So once again, when I put my x's together, I have 1x and 1x, which just gives me 2x. So now I have x squared plus 2x plus 1. Over here I have, bring down the x squared plus 49. Now here's what's good about this problem that didn't happen on the last problem. If you'll notice, you've got x squared on both sides. Remember, you can do anything you want to one side as long as you do it to the other, which means if I subtract x squared, I have to do it to both sides, which fortunately just cancels them on both sides. So now all I have is 49 equals 2x plus 1. So I don't have a quadratic equation anymore because I don't have any x squareds. So now I just need to solve this equation for x. So get x by itself by subtracting 1 on both sides. So now I have 48 equals 2x. Divide by 2. So x equals 48 divided by 2 gives me 24. So let's go back up to our picture and see what this represents. So the x is 24. So this side right here, that's 24. But if you'll remember, it asks me what the length of the ladder is. So this is our ladder in the picture, which means I need to know what x plus 1 is, which is 25 is the length of the ladder.